All right, y'all, so in this lesson, we're going to be looking at special right triangles, which are a type of right triangles that have very predictable patterns to their sides. That's because they follow a certain set of proportions. So there's two types of special right triangles, 45, 45, 90, and 30, 60, 90 triangles. And we're going to be talking about that first one in this video. I'll make a second video over 30, 60, 90 triangles. One thing to note about these triangles is that the names are the angle measurements. So if a 45, 45, 90 triangle is what we're dealing with, that means the triangle has 45-degree angles here, here and here, and it has a 90-degree angle here. So those are the angle measurements. Now, since I have two angles that are the same, that means I have two sides that are the same, which makes this an isosceles right triangle. And like I said, these follow a certain ratio, that ratio being 1 to 1 to the square root of 2. Now, one thing to remember, and this is important, is that the ratio 1 to 1 to the square root of 2 is actually more like this. Because there's an understood 1 in front of any square root sign. Just like there's an understood 1 in front of x. Like if I was dealing with x plus 3, there's a 1 right there. Okay? So that's the same thing as with a square root. That's also called a radical, the square root sign. So the ratio is 1 to 1 to 1 square roots of 2, but we're often going to see dilations. And actually, that's where we're going to see most of these triangles. So anytime this triangle gets bigger, it's going to be in some kind of ratio. So if the leg is 5, then this leg is 5, and this leg is 5, and this leg is 5 square roots of 2. So really that 1 acts not as a 1, but as kind of an x. So that acts as like an x to x to x square roots of 2. And whatever we put in that x value is always going to be the same. Let me show you an example down here at the bottom. On example 1, I'm given a 45, 45, 90 triangle. Now, this doesn't tell me that it's a 45, 45, 90. I have to recognize that for myself. But I can see that these two angles are congruent, and this is a right angle. So those two angles have to be the same, which means there's 90 degrees divided by 2, so they're both 45. This tells me that I have a 45, 45, 90 right triangle. And I know about those triangles that the legs are the same. Now, this value for y is the hypotenuse, because it's across from the right angle. So my other leg, x, is also 4, just like this leg. I also know, since this is a 45, 45, 90, that y is now 4 square roots of 2. So I've got 4, 4, and 4 square roots of 2. There's 3 4s in that problem. Same number. The only difference is the hypotenuse has a square root out front. So what's really going on behind that is that anytime I'm going from my leg, if I'm given my leg, and I want to find my hypotenuse, we're going to multiply by the square root of 2. We're going to multiply by the square root of 2. And anytime I'm going from my leg to another leg, if I know one leg and I need the other leg, well, it's the same, since it's isosceles. So those are the same length. Now, what happens if I'm given my hypotenuse, but I need to find my leg? In that case, we're going to be going backwards from our hypotenuse to our leg. So the opposite of multiplication is division. We're going to divide by the square root of 2 instead of multiplying. So we're just going to write that down. We're going to do an example of that in just a second. So we have, if we start from our hypotenuse, and we want to find a leg, we're going to divide by the square root of 2. We're actually going to see that in example 3. So let's do that one first. I'm going to change example 3, and we're going to make it so that that's just 10, and that's not 10 squared root of 2. So now I've got a problem where I'm given the hypotenuse is 10, and I want to find G and H. So then G is 10 divided by the square root of 2, and H is 10 divided by the square root of 2. But I can't stop there. One of the properties of radical expressions is that I can't have a radical or a square root on the bottom. It's not allowed. So what I have to do is I have to multiply by a special 1. Remember, anytime you multiply something by 1, it doesn't change the value, so I'm okay to do that. So I'm going to multiply by a special 1, and that's going to help me change my value to look a little bit nicer and cleaner. You're not going to be expected to do this a ton, but it does show up enough that I want you to see how it's done so that you can reference this if you need to. So we've got 10 over the square root of 2 times a special 1. And the way that I'm going to make that special 1 is by taking the number on the bottom and then repeating it 2 more times. So square root of 2 over the square root of 2. Anything divided by itself is 1, so that works. That's just multiplying by 1. So I'm going to multiply across the top and multiply across the bottom. So I have 10 square roots of 2 over the square root of 2 times the square root of 2. Now, one of the properties of square roots lets me multiply 2 square roots that are next to each other. I can multiply this stuff inside, and I can just group them together. So this lets me say that that's equal to 10 square roots of 2 over the square root of 2 times 2, which is 4. And we should know that the square root of 4 is 2. So we've got 10 square roots of 2 over 2. We can simplify, so that's 10 square roots of 2 over 2. And 10 divided by 2 is 5. So our final solution is 5 square roots of 2, which equals the same thing as 10 over the square root of 2. It's just a little bit cleaner because we don't have a fraction, we don't have a radical in the denominator, which is not allowed. Okay, you're not going to see that a ton, but you will see it enough that it's necessary. Okay, let's look at another easy one. Number 2, we're given the leg. Since this is a 45, 45, 90, since these two legs are the same, we know that this side is 3, and we know that the hypotenuse is 3 times the square root of 2, or just 3 square roots of 2. Pretty simple, not too bad to see. Remember, these two answers are both for those sides. Okay. In our next video, I'm going to be talking to us about this the 30, 60, 90 special right triangles. They also have some proportions, but they're a little bit different. So we'll talk about those in just a little bit.